Welcome everyone. We are discussing Bayes' theorem. Today I will discuss some moderate problem of Bayes' theorem. So you know the theory already. So we will discuss some moderate problem today. Now problem number 1. This is very simple problem. 5 men out of 100 and 25 women out of 1000 are good orators. An orator is selected at random. Find the probability that male person is selected. Assume that there are equal number of men and women. So, this to be noted. Equal number of men and women. So, equal number E1 equals to even that. So, we know the theory already discussed. PE1 by A equals to PEI into PA by EY by summation PEI into PA by EI I equals to 1 to n. So, here there are only two events. E1 equals to event that male orator is chosen. E2 equals to woman. So, PE1 equals to PE2 equals to 1 by 2 because there are equal number of men and women. Now, you have to define a event A. So, what is the event A? Associated with E1 and E2. So, find the probability that a male person is selected. An orator is selected at random. So, A equals to event that an orator is selected. Orator is selected. Orator is selected. An orator is chosen at random. So, this is A related with E1 and E2. So, P A by E1. Orator from men. Probability of orator from men. So, 5 men out of 100. So, 5 by 100. So, 1 by 20. So, P A by E2. Orator from female. 25 by 1000. So, 1 by 40. This is 1 by 40. So, what is probability of orator? It may be from men and it may be from women. That is total probability. So, PA equals to PE1 into PA by E1 plus PE2 into PA by E2. So, PE1 half, then 1 by 20, half 1 by 40. So, half common 1 by 20 plus 1 by 40. So, this is PA. Now, you have to find the probability that male orator is selected. Probability of male orator E1 by A. Orator from male. So, PE1 by A. So, this is PE1 into PA by E1 by PA. So, what is PE1? Half A by E1 is 1 by 20. This is half common 1 by 20, 1 by 40. So, half is cancelled out. So 1 by 20, this is 40 is LCM. This is 2 plus 1, this is 3. So finally 2 by 3. 2 by 3. So this is very simple problem of board for Wbjee. So this is simplest problem. Now we consider second type of problem. So two same type of problem. A letter is known to come from London. A letter is known to come from London or Clifton. On the envelope, just two consecutive letters ON are visible. What is the probability that letter has come from London? So letter has come from two places, London and Clifton. So London. And second one is Clifton. So there are two events you have to define. So what is event 1? E1 equals to event that letter has come from London, and E2 event that letter has come from Clifton. So we have to define two event E1 and E2. So there are two places. So probability PE1 equals to PE2 equals to half. So sum of them is 1. So this is first step. Now we have to define an event associated with E1 and E2. So it will be clear from problem. So on the envelope, just two consecutive letters ON are visible. So ON are visible. A equals to event that two consecutive letters ON are visible. So look, what is P A by E1? ON visible from London. So look, 1, 2, 1, 2, 3, 4, 5. So 6 letters. So how many consecutive letters? So 5 pairs of consecutive letters. So 5 pairs of consecutive letters. So you have to take 1. 5C1. That is 5. And ON. So this one, 2 is ON. 1 consecutive and ON. So this is 2. So 2 favorable cases. So 2C1. That is 2 by 5. We can write it PA by E1 is 2 by 5. So this to be noted. How many consecutive? Total number of consecutive letters. So 5. So 6. So consecutive is 1 less 5 and 2 ON. Here it is and here it is. Now in Clifton, 7 letters. So how many consecutives? So PA by E2. So 7. So it will be 6. So let us verify. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6. So 6 consecutive letters. You have to take 1. So how many ON? 2 consecutive letters ON. So only 1. That is the 6th one. So this is 1 by 6. So this to be noted. Then it is very simple. Find PA. What is total probability? PA. So PE1 into PA by E1 PE2, PA by E2. No need of writing if it is problem of competition. So half common. So 2 by 5 plus 1 by 6. So this is PA. Now the last step, that is the Bayes theorem, application of Bayes theorem. Up to this is total probability. What is the probability that letter has come from London? So we have taken London as E1. So required probability E1 by A. So this is required probability. So from definition, this is PE1, PA by E1 by PA. So PE1 half into 2 by 5. Half into 2 by 5 plus 1 by 6. So half cancel. So 2 by 5 and LCM is 30. So it will be reciprocal. So this is 12 plus 5, 17. 12 plus 5, 17. So this is 6. So 12 by 17. So what is the required probability? Required probability is 12 by 17. Now there are only two events E1 and E2. If it is given what is probability that letter has come from Clipton, so 1 minus 12 by 17. So listen again. E1 and E2 are two events. A is event associated with E1 and E2. Just two consecutive letters when are visible. A by E1. So this should be noted. So 6 letters. So 5 consecutive. Out of 5 you have to take 1. And there are 2. Out of 2 you have to take. And similarly A by E2 1 by 6. Then find PA. Then PE1 by A. So problem number, this is 2 and this is 3. 2 and 3 are of same type. So you complete the second one. This is exactly same problem. Now you consider two same type of problem. So 4 and 5. A is known to speak truth. A is known to speak truth 3 times out of 5. He throws a die and reports that it is 1. Find the probability that it is actually 1. So this is important problem for board as well as JEE Main and Wbjee. This problem has come in JEE in several times, in Wbjee also. So look, A is known to speak 3 times out of 5. He throws a die and reports that it is 1. Find the probability that it is actually 1. So a die is thrown and he reports 1. But he does not speak truth always. That is why, so reporting is not true. So what is the probability that it is actually 1? What is the probability that report is correct? So here we have to define two events E1 and E2. So E1 equals to event of getting 1 in a single throw of a die. So E2, event of not getting 1. Not getting 1. So PE1 equals to P1 by 6 and PE2 5 by 6. So E1 plus E2 1. So exclusive and exhaustive. This is criterion of Bayes' theorem. Now we have to define an event A related with E1 and E2. He throws a die and reports that it is 1. A suman event that he reports 1. So P A by E1. So this step to be noted. A by E1, he reports that it is 1 when 1 is actually occurred. Report that it is 1 and 1 is actually occurred. Report is 1 and 1 is actually occurred. That is, he speaks the truth. He speaks the truth. So A by A1, probability that he reports 1 when 1 has actually occurred. That is, probability that he speaks the truth. He speaks the truth. So this step, this line to be noted. You have to write this line for board problem. So what is the probability of speaking truth? So 3 times out of 5. So this is 3 by 5. 3 by 5. Now A by E2. Now it is very simple. Probability that he reports 1. This is A. What is E2? When 1 has not occurred. He reports that it is 1, but 1 is not occurred. That is, he tells the lie. That is, probability that he tells lie. So this is 2 by 5. 3, 5, this is 2 by 5. So this step. Now, total probability. What is PA? PA is PE1 into PA by E1 plus PE2 into PA by E2. So 1 by 6 into 3 by 5 plus 5 by 6 into 2 by 5. So 30 is LCM. 30, and this is 3, this is 10, this is 13. 13 by 30. This is total probability. He reports that it is 1. Now what is required probability? Find the probability that it is actually 1. It is actually 1. Actually 1, this is E1. So required probability equals to P E1 by A. So what is P E1 by A? P E1 into P A by E1 by PA. So what is PA? PA is 13 by 30, and this is 1 by 6 into A by E1. A by E1 is 3 by 5. So 3 by 13. 3 by 13 is final answer. So this is interesting problem also. So look, E1 to be defined. So you do not take that E1 equals to event of telling truth and E2 is event of telling lie. Do not use E1 and E2 in this manner because you cannot find A by E1 in this case. So problem number 5, exactly same problem. So this you complete this problem. Now we consider another type of problem. A card from a pack of 52 is lost. From the remaining cards, 2 are drawn and found to be hearts. Find the probability that missing card to be a heart. So you know 4 type of cards according to their name. So diamond, 13, hearts, 13, spade, 13, clubs, 13. So hearts, spade, and clubs. So they are of black color. All of you know it, they are of red. So from a card from a pack of 52 is lost. So card may be lost. Card may be of 4 types: diamond, heart, spade, and clubs. From the remaining cards of pack, 2 are drawn and found to be hearts. Find the probability that missing card is heart. So it is with respect to heart. So you can consider the problem by 2 ways. So number 1 is heart card and non-heart card. And number 2, defining 4 events: heart card, diamond cards, spade card, and clubs. So we define E1 and E2. So this is hearts and non-hearts with respect to hearts and non-hearts. So E1 equals to event of heart cards. E2 equals to event of non-heart cards. So what is PE1? Event that lost card is heart. Event that lost card is not heart. So E1 and E2, because one card is lost. So what is PU1? 13C1 by 52C1. So 1 by 4. So this is PE1. And how many non-heart cards? PE2. So 39C1 by 52C1. So 3 by 4. So these two are equal. This plus this is equal. So they are exclusive and exhaustive. Otherwise, PE2 lost card is diamond. So this is 1 by 4. Lost card is spade, 1 by 4. Lost card is clubs, 1 by 4. So 1 by 4, 4 times added is 1. You may use this also. Then you have to define event associated with E1 and E2. So from remaining cards of pack, 2 are drawn and found to be hearts. So E equals to event of drawing 2 heart cards. So P A by E1. This step to be noted. A by E1. 2 heart cards. When 1 heart card is lost. Event of drawing 2 heart cards when 1 heart card is lost. So total hearts 13, 1 lost, so 13 minus 1, this is 12. So from 12 you have to take 2, 12C2 by 51C2. 12C2 by 51C2. So this is 12 into 11 and this is 51 into 50. Factorial to cancel. So this is 4 and this is 17 and this is 2, this is 25. So 22 by 25 into, so 4 to 5. This is 4 to 5. Now PA by E2, this step to be noted. Drawing two heart cards when lost card is not heart. Lost card is not heart. So this will be not subtracted. So look, it is lost card is not heart. So this is 13 C2 by 51 C2 because total heart cards is 13. Sorry, arrow will be here, tick mark. So this is 13 into 12 by 51 into 52. So this is 4 and this is 17 and this is 51 into 50. So this is 2. This is 25. So 26 by 4 to 5. 4 to 5. Now find total probability. So total probability that two cards drawn are hearts. PE1, PA by E1 plus PE2, PA by E2. So this is 1 by 4 into 22 by 4 to 5. This is 3 by 4, 26 by 4 to 5. Now 1 by 4 common. So 22 and this is 78. 78 plus 22. So this is 100. 100 by 4 to 5. Now what is required probability? Find the probability that missing card to be heart. So missing card to be heart. Missing card to be heart is E1. So P E1 by A. This is required probability. So P E1 into P A by E1. And this is by PA. So this is 1 by 4. A by E1. So what is A by E1? A by E1 is, this is 22 by 4 to 5. And what is PA? 1 by 4, 100 by 4 to 5. So 1 by 4 is cancelled out. So this is 11 by 50. 11. 22 by 100, 11 by 50. So a card from a pack of 52 is lost from remaining cards. So E1 equals to event that lost card is heart, E2 event that lost card is non-heart. From remaining cards, 2 cards are drawn and found to be heart. A equals to event of drawing 2 heart cards. So A by E1 and A by E2. Find PA, PE1 by A. So there is similar type of problem. A card from a pack of 52 is lost. From the remaining cards of pack, 1 is drawn and found to be heart. Find the probability that missing card to be heart. So this is same type of problem. 2 is replaced by 1. So you solve this one. So today through this video we have solved some interesting problem of Bayes' theorem. So you practice this type of problem from your textbook. Thank you for today.